So, hi everyone, welcome back to Data Science in Your Pocket. And today we are exploring a new topic, that is fine tuning audio TTS model, that is text to speech models. So, for now, I think most of the tutorials are revolving around fine tuning of text generation models, be it Quen, Phi, Llama, etc. What I think recently Unsloth has released a script around fine tuning TTS models in your audio. So, that's the best part. So we would be trying out fine-tuning TTS models using Sesame CSM1B. It is one of the best conversational AI models that exist, and we will try to fine-tune it in custom data set using a given script. So a big thanks to Unsloth for that. This is not a paid promotion, so don't worry about it. Now let's jump on to the codes. So you can see that we would be first of all starting off with pip installing a few required libraries. I think some of them you might be knowing them: bits and bytes, accelerate, xformers, peft for implementing LoRa. I'll be telling you everything in detail, don't worry about it. Hugging Face Hub and HF transfer would be required for uploading your model. I'm not doing that for now. Unsloth is required because we would be using Unsloth to fine tune. Why Unsloth? Because it requires less GPU. Also, it is way faster compared to traditional Hugging Face trainer. So I've already covered a video and a post on Unsloth previously. Now we are extending that. So once you are able to pip install this, link to the script is present in the comment section below. So don't worry about it. We'll be now jumping on to the next part, that is loading the CSM1B model. As you can see here, we are choosing the fast model, supports loading nearly any model now. It includes vision and text models. So using Unsloth's fast model version, you can even fine tune vision models also, right? And it helps in faster fine tuning of LLMs. The model name is Unsloth CSM1B. Maximum sequence it can accept is about 20,000. Data type we are not mentioning that. Auto model is CSM for conditional generation taken from transformers only. This is important. Load in 4-bit. It can be true, it can be false. If we are making it true, the 4-bit version of Sesame CSM1B would be loaded. Accuracy will take a hit, but if you're lacking on GPU and on hardware resources, this is the best thing to do, right? Once done here, you can see that this is the config that you should see. Now the next part is you will be adding LoRa adapters. So to update 1 to 10% of the total parameters. I think if you have been knowing about fine tuning and pre-training, you have heard of this term LoRa, Q LoRa, D LoRa. So I'll tell you what happens here. It is sort of, not exactly, sort of a matrix decomposition technique that people have come to know, where fine tuning can be done without updating all the parameters, as you can see. So we will need to update just 1 to 10% of the total parameters and getting almost the same accuracy that you will get with full fine tuning. It won't be exactly the same, a little lower, but you would be saving huge time on your resources as well as the time taken. So I have already explained LoRa in quite some detail in my previous videos. I've just given that link in the comment section again. You can check that out how LoRa works. So here you can see that we are first of all setting up the most important parameter, that is R equals to 32. That is a dimension of LoRa. As he mentioned here, choose any number greater than 0, 8, 16, 32, 64, 128. The bigger the model, the better would be the accuracy, but more the parameters that would be trained, right? So remember this. Target modules, which weight matrices you wish to fine tune. It won't be fine tuning the entire model, it would be fine tuning just the matrices that you're mentioning. So here you can see that KQV you might be knowing from attention, O down, up, gate projection. So you need to understand the architecture of CSM1B to understand these modules. I'm not jumping much into it, but just giving you a hint how a TTS model can be trained. LoRa alpha, LoRa dropout, these are parameters related to LoRa. I'm not jumping into that also much. You can read about LoRa and find and change these hyperparameters accordingly. Once this is done, the most important part is the data preparation. What data set to use? So here you can see that one important point is we are loading an auto processor from pre-trained, that is Unsloth CSM1B. This is an upgraded version of tokenizers. So if you have worked with LLMs in local inferencing, you might be knowing there is a object called as tokenizer that is also getting loaded. So in case of audio models, tokenizer takes a much more bigger role, that is a processor, as you mentioned here. It not just tokenize, it does a lot more things also, because see, audio is any day more complex than text. I think you might be understanding that, because it's not straight away text versions. You'd be having some wavelength, some numbers coming into the picture. It is a completely different format, hence some more processing is required. The data set that is getting used in this script by Unsloth is Mr. Dragon Fox Elise audio. So I'll be showing you that the data set also. So here is the data set, as you can see, present on Hugging Face, and it has the audio of 10 seconds and the length, what text it is saying. So let's listen to a few of the audios.
The borrowers. Yeah. Beneath the floorboards. Just dozens of them. Can I get my scritchies now? Oh, but I thought you didn't want any scritchies. Please have mercy on my dainty frail body.
So as you can hear, it's a female voice with a sort of whispering sort of an audio. So this was a data set. As mentioned here, as you can read here, ensure that the dataset follows audio for single speaker models or source text audio for multi-speaker models. There is a certain format you need to know if you're using it for your customized dataset. Do remember that it has to be an audio, the text should be present for ground truth and other details. Source should be present. If source is not present, because CSM1B works on the idea of dialogues, so you need to provide speaker 0, speaker 1, speaker 2 sort of IDs for the text that is getting spoken. So if that is present, that's great. Else, in this particular script, we are already adding a default username. As you can see, no speaker found. We would be adding default 0 for all the examples. So you can train out using multiple speakers also. This dataset was having just one audio. As you can see here, they are adding the speaker ID here, and some sort of pre-processing of the dataset is happening. This is an important point here, where you're providing the actual prompt, how CSM1B is able to intake a input. So this conversational format has to be followed. So once you're loading your dataset, you need to convert it into this particular format for training. As you can see, text is present, audio is present, and the role is the ID. It can be 0, 1, 2, 3, 4, etc. Then some sort of pre-processing is happening here. As you can read, padding is done, padding side, pad to multiple of what. This is a processor dot apply chat. So processor, if you remember, was the upgraded version of tokenizer that we loaded initially. So here we are passing the conversation, that is the template that we have created in the first step. Return date, output labels, audio key arguments, etc. And here some basic checks are done in this particular section, that all the required fields are present or not in the pre-processed data set. Because see, audio is a little complex, hence some checks are done so that if any audio doesn't have it, that sample would be removed. These are certain checks, final check, as you can read, these are certain checks for sanity purposes. And here raw dataset dot map, you are now mapping it to this particular function for getting its pre-processed version for training purposes. Now we are coming back to the actual part, that is training. What parameters to use? So eventually it's quite easy. We are again using transformers trainer. As you can see, model is model, that is CSM1B. Dataset is a pre-processed dataset that we did, and here are the training arguments, as you can see. So these training arguments are typical arguments for training or fine-tuning any LLM. As you remember, max steps, linear learning rate, floating point 16, B float, optimizer is Adam W, weight decay, etc. I'm not jumping into these are a little technical. And if you want to go, you can go with the default ones. Do mention the number of epochs, either number train epochs equals to 1, because what is happening here, we are mentioning max steps equals to 60, hence this is overriding the epochs parameter. If you mention epochs, then that would be taken up. Once done, we have started the training. As you can see, the loss is reducing for 60 steps. Within 60 steps, you won't get anything much, but just to demonstrate. And here, how to use your model once you are able to train it. And do remember that we are doing this on Google Colab. So that's the best part. It is able to train a huge 1 billion parameter model, fine tune it on Google Colab. That is the free GPU. Now here you can see that we are now coming back for inferencing of the fine-tuned model. We just finished fine-tuning a text-to-speech model and it's pretty good. Speaker ID is 0 that we gave initially, and here using the preprocessor again we are creating that particular template for the model to understand and generate. Here you can see that the maximum token is 125, audio is getting generated from this particular snippet, and then audio is generated here.
We just finished fine-tuning a text-to-speech model. And it's pretty good. We just finished.
So if you heard the few samples that we shared earlier from the actual data set, it is sounding very much that within just 60 steps, if you train it for 100 or 1000, 2000 steps, that would be crazy enough to get you an TTS model speaking in your language. The other things also that they have done, some other examples also.
Sesame is a super cool TTS model, which can be fine-tuned with Unsloth.
So the model itself is quite good. This is how you can fine tune an audio TTS model for free without paying in a single penny for GPU on Google Colab, courtesy Unsloth. And this is quite fast also. I think it took me just 5 to 10 minutes to fine tune the entire model, and the audio that you're hearing is quite good. I think I will try to fine tune my audio because I have now got some samples after creating so many videos, and will try to share the results what I get from my audio. Also, by the time, I would highly suggest you all to try out fine tuning TTS models because audio AI is the future. Thank you so much. I hope this was useful.